For a system of equations given in generic form here as ax plus by equals e, cx plus dy equals f, where a, b, c, d, e, and f are real numbers, so constants and coefficients, and x and y is our variable, and we're trying to solve for the variable that makes the system of equations true, or for the variables, you know, the ordered pair x, y, like we've been doing already in chapter 6. So we can actually do this using an inverse matrix. So to do that, think of it this way as just a little equation, a times x equals b, which means x would be found by taking b divided by a, but we don't have matrix division. So instead of division, we use the inverse. If it were an actual just number instead of a matrix, it would be a reciprocal. That is the same thing as divide, but in this case, it's an entire inverse. It's the same thing, times our constant matrix. So these are the matrices that would fit into this type of equation. Matrix A would be our coefficients of our variables. Matrix X would be our variables. And matrix B would be our constants. So these are just letters representing those numbers in a generic situation. And because this equation matches up with this situation, this is what this would look like to solve it. So we would be able to find our xy values, or if we had all three, it would be xyz values, by taking the inverse of the coefficient matrix and multiplying it times the constant matrix, and we will get a matrix containing those answers. That's really easy to do with the calculator. Let's look at the examples we have to do here. So I'm going to go ahead and kind of clear this out so we can start from scratch. So here we go. We are going to start by turning our system of equations into matrices. So we're going to have matrix A is 3, 8, 4, 11. Remember, that's our coefficient matrix. And then we have matrix B, or X, I guess is the next one, would be our XY, right? And then the constants would be 5, 7. So to solve this problem, in order to find our XY values, we are going to take the inverse of 3, 8, 4, 11, and we're going to multiply that times matrix B. I'm going to show you first with a calculator. So here's my calculator. My matrix is 3, 8, 4, 11. Okay, so I'm going to my button where I can pull up a matrix. I want a 2 by 2. So I already can't remember. 4, was it 4? I'm looking. 3, 8, 4, 11. 3, 8, 4, 11. Okay, so we can do our inverse, find the inverse this way. I'm actually going to just throw this whole problem in here at the same time to show you what this will look like, just using the calculator. So I want that shape of matrix, and that was the one I wanted 5, 7, right? So these are my coefficients. This is the inverse. This is the constants. I'm going to hit enter, and I get -1, 1. So the solutions are x equals -1, y equals +1, -1 comma y, if you want to write it as an ordered pair. We can also do this just kind of separately. So let's start over. I'm going to take my matrix, 2 by 2 matrix, and do my 3, 8, 4, 11 again, and do that -1 power, hit enter, and that gives me the inverse matrix, 11, -8, -4, 3. Okay, now that we've looked at the calculator part of things, so we could actually manually type that in, times this one, and then get the same answer that way, or we could manually multiply it now that we have that inverse, just multiply it together to get the answer. Okay, let's go do the whole thing by hand. I know, this is so exciting. So we're going to find inverse first. So to do that, I'm going to go ahead and use the formula. You can always use row operations. So for the formula, I go 1 over 3 times 11, so that's 33, minus 4 times 8, so 32, so that's just 1. We've seen this before. So we trade the 11 and the 3, and we change the signs on those. And there's our inverse because we multiply by 1 and nothing changes. So probably didn't need to write that all out with that 1 because it was obvious. So there's our inverse, right? So then our inverse, a negative 1 times b, is what we're doing. So inverse is 11, negative 8, negative 4, 3. And we're going to multiply that times our constant matrix 5, 7. So we're just going to take row 1 times the column, which gives us 11 times 5, or 55, negative 8 times 7, which is negative 56. We're adding those together. It just happened to be a negative number, so it looks like it's subtracting, but it's adding a negative 56. So that gives us a negative 1. And then moving this down to here, we only have the one column, so that part isn't going to change. It's annoying, my whole thing is moving. You get the idea. So we have negative 4 times 5 is negative 20, and 3 times 7 is positive 21. So that gives us positive 1. So this is our answer matrix, which means our answer is x equals negative 1, y equals 1. There's our ordered pair with our solution to our system of equations. Okay, so since I just did a video finding the inverse on example 4, both by calculator and by hand, we do not need to find the inverse again, because the good news is this coefficient matrix, when we take all these coefficients and turn it into our coefficient matrix A, is the exact same matrix that we found the inverse of in example 4. So here it is. Refer back to that video to see that process again if you need to. We used the row echelon form. We also used calculator and saw how to find that in 2 different ways, right? So then the constants are 4, 2, 5. So that's our matrix B. So to find our variables x, y, and z, we just take matrix, the inverse matrix that we found in example 4, we multiply it times the constant matrix, matrix B. So we take our first row times our one column, negative 1 times 4 is negative 4, 1 times 2 is 2, 0 times 5 is 0, negative 1 times is 4 is negative 4, 0 times 2 is 0, 1 times 5 is 5, and then 6 times 4 is 24, negative 2 times 2 is negative 4, negative 3 times 5 is negative 15. We add this together, so negative 4 plus 2 plus 0, negative 4 plus 0 plus 5, 24 minus 4 minus 15. We get these three answers for x, y, and z, and so our ordered triple for this 3 by 3 is negative 2, 1, 5 for x, y, and z. The second example on this problem has exactly the same equations other than the constants. So the coefficients are exactly the same, the coefficient matrix is the same, the inverse is the same. We're just multiplying times a different set of constants, and that will give us a different. Okay, while the announcements were on, I went ahead and did this problem. So we have negative 1 times 11, 1 times negative 2, 0 times 15. Got these three numbers, add them together, I got negative 13. Then I did negative 1 times 11 is negative 11, 0 times negative 2 is 0, 1 times 15 is 15. Add those together, I got 4. And then 6 times 11 is 66, negative 2 times negative 2 is positive 4, negative 3 times 15 is negative 45, 66 and 4 is 70, minus 45 is 25. I think I subtracted that correctly, which would give us the answers x, y, z, negative 13, 4, 25. So we're just kind of reusing that work we did on example 4 to do two other problems showing you just take that inverse that you already know, you multiply the constant matrix, you find the answers. And that is probably the type of problem that would be on your final exam. At least that's what they've done in the past. So with that, we're done with 6.4, 6.5. We're ready for 6.6, which is a different method called Cramer's Rule. Lots of people like Cramer's Rule. So we'll get to see that on Friday, and hopefully we'll see you here for a Google Meet.